Hello, everyone. Thanks for joining. We are going to go over Amazon ECS Anywhere. This is the new product offering that we launched recently in May of 2021. My name is Arvind Soni. I work as a senior containers specialist here with the AWS team. We are going to do a quick recap of ECS and containers, and then from there we'll build on the use cases where ECS Anywhere fits in. Then we will take a closer look. We'll do a walkthrough of a detailed use case aligning with the hybrid kind of scenario that we see with ECS Anywhere. Then I'm going to capture some of the other common use cases that we have heard with the customers that engaged during the beta and are using after the release of the product. And we can wrap it up with some of the questions and answers. All the resources that I'm using for the demo and everything are available on GitHub, so you can try it. And there is a full, very nice workshop also available. So I'll point to those resources as well. So let's just start with a simple question. Why containers? Safe to say that containers have become the standard packaging for our software. And the reason is simple. Customers want to use containers because they want to innovate faster and they want to innovate better. By better, I mean more efficiently. And the way to do it is containers being a portable and a consistent packaging format allows customers to build end-to-end automation. So think of it just like an assembly line where you manufacture cars, right? So it's exactly like that, but for software. So you have your CI/CD pipeline, you build your application, you package it as a container. That's the CI/CD part, the build and deployment part. And once the containers are built, then you use an orchestration service to provision a compute and a network and a storage so that that container can actually run and deliver the application that you want. The orchestration also provides built-in features such as auto scaling, and if the container dies, it will heal it and resurrect or spawn a new task based on the same container. So these auto scaling and self-healing also help you gain the operational efficiency. So that is that part of innovate better, right? Additionally, containers, you can pack them better in the underlying container host. So that will lead to better utilization. And together with automation, you will have cost efficiency. Okay. And once you have the applications running, you are going to instrument it for observability. You will instrument it to gather the logs, metrics, alerts, so that you can ensure the security and health of the application. And all of those aspects are also very easy to standardize and automate with the containers. So that's the reason why containers have become the de facto standard for delivering the software. And automation is the key to achieving all of those values. And a central piece in that automation is that orchestration service, which essentially gets the containers running and provides you features such as auto scaling, self-healing, provisions all the infrastructure and configures it, and so on and so forth. And that service is one of the orchestration services that we have is the Amazon Elastic Container Service, also known as the ECS. Okay, some quick information about Amazon ECS. It's a fully managed container service, first of all, and that's brilliant because you don't have to manage any control plane. You don't have to upgrade any control plane. There is no hassle for versioning and managing and securing the control plane. It is fully managed by AWS. It's a fully managed container service, just like EC2 is a fully managed virtual machine service. The second important aspect is that customers love very much is the broad range of compute options. Pretty much all the EC2 options that are there, you can use them to run containers. You can also use Fargate, which is rapidly growing and is the serverless paradigm. Essentially, you don't need to manage any container host. We manage the container host for you. All you need to do is bring your containers and build that CI/CD pipeline and focus on that automation. We will provision the container host, we will secure it, we'll maintain it. And it is also very easy to scale because you don't have to worry about the underlying compute. And you can use the spot variants for both EC2 as well as Fargate. So that helps you save money about at about 50 to 70% less cost, right? The third thing is ECS is a complete orchestration service. So right from hooking up to your deployment service all the way to provisioning the compute, the network, the storage, and also things like pulling up the configuration for the container during the runtime, scaling them up and down. And if the container fails, ECS can respawn another replacement task. So all of this end-to-end orchestration is provided out of the box by ECS. So really beautiful. You can focus on building that automation. You can focus on delivering the innovation fast by using ECS. And then icing on the cake is that it is completely free. There is no charge for using ECS. The only thing you get charged for is all the compute resources and other resources that you use. The service ECS itself is completely free. So free, fully managed service with a serverless option to run the containers is why a lot of customers love ECS, and it helps them innovate faster, it helps them innovate better, and focus on their automation. And ECS performs at really large scale, right? Like it powers some of the most heavily utilized Amazon services. For example, when you go to Amazon.com and you see those recommended items list, that is powered by ECS in the backend. AWS Batch is powered by ECS. Some of the new cutting-edge AI ML-based services such as Lex and Poly are also powered by ECS. So it's a really powerful, really scalable solution which can handle large amounts of workloads and large demand on your business applications. It's not just Amazon, but pretty much customers of all sizes across all the verticals are innovating quickly with ECS, right? Remember that there is no control plane for you to manage. If you're using Fargate, no data plane for you to manage. It's a really cost-effective solution for the customers to focus on their apps. So whether you are Disney Plus streaming, videos 24/7 to millions of subscribers, or whether you are Vanguard managing, trillions of dollars in investment, or you're a young company like Aerobotics or Babel, trying to solve some really difficult problems. In case of Aerobotics, they are doing imaging of the farm so that they focus on better crop yields. And in case of Babel, it's the very famous language translation or language learning application. So you can see that the wide spectrum of customers of all shapes and sizes across all the verticals benefit heavily from the powerful simplicity of ECS, where you can focus on your application and we focus on the managing the container lifecycle. And based on the feedback of these hundreds of thousands of users on ECS, we have evolved the options where you can run the containers. We, of course, support all the AWS regions and the EC2 and the Fargate variants over there. Then the local zones, wavelength, outpost, they're all supported. But what we heard from the customers is that there are various scenarios where customers need to run the containers on self-managed compute. And that's where ECS Anywhere comes in. With ECS Anywhere, we are expanding the Amazon ECS service so that you can run the containers on a self-managed compute, which is not under the management of AWS. So it's your compute, but it's the same ECS, okay? And the reasons could be many. It could be as simple as you have existing investments, existing hardware that you want to amortize. It could be the fact that there are some compliance-sensitive workloads or data sovereignty restrictions for which you need to run it on the hardware that is under your control. Or it could just be that there are a lot of legacy systems and essentially the data that is tied into that systems, and you need these containers, at least for a short period of time, to be running on-prem and in close proximity to those legacy systems, right? So the data gravity and proximity also is a good reason. Whatever be the reason, one key thing that we heard from the customers is that I don't want to create another orchestration system, another CI/CD, and another, the complete operational pipeline just to run containers on-prem. So that's why with ECS Anywhere, we want to maintain the same fully managed control plane, but let you bring in your compute and let you launch the containers on those compute. And that's why we launched ECS Anywhere. Essentially, you can run containers really anywhere. And we have already seen customers wanting to run it as exotic a places as the ship, which is actually taking images of the underwater internet cables, right, to the factory floors where there are smart machines beaming a lot of data, to the hospitals, to retail sites, right? So it's not just your traditional on-premise data center. It's really anywhere that you want to run containers, that we want to power it with ECS Anywhere. And that's why we are very excited, because it really unlocks a lot of innovative use cases across all sorts of customers that we already have. So we are very excited about ECS Anywhere. But we had like few key tenets, if you may, that we wanted to ensure with ECS Anywhere. The first is that powerful simplicity aspect of ECS. We want to make sure that the control plane is managed by AWS and it does not incur any operational overhead on the customers. Remember, that is the simplicity, and it makes it really easy for the customer to focus on their app. So the ECS Anywhere control plane is the same ECS control plane that runs containers in the cloud. It's a fully managed control plane. Customer doesn't have to do any upgrade or any complex software installation, anything like that. The second is the information exchange between your data plane, essentially your self-managed compute, and the control plane is kept to a minimal. Only things like the cluster health and the container health and the capacity, those minimal information are transmitted and exchanged between the control plane and the data plane. The third is the containers run at an OS level of abstraction. So we don't necessarily care about whether it's a bare metal or virtualization. So in that regard, we want to free the customers to choose whatever is the best for their self-managed compute and whatever expands the options for them. From our perspective, all we need is the operating system which can run the containers. Yeah, and a full list of supported OS is published in the documentation. Now, since the control plane is in the cloud and the data plane is under your management, there could be scenarios where there's an internet disconnect between the two. In those scenarios, we want to make sure that your task continues to run. We are not going to do any disturbances to the task and applications. And of course, there's built-in logic so that when the connection is established, we will reconcile to the state that you desire. So those are the tenets. And those are the guiding principles behind ECS Anywhere. So let's see, how does ECS Anywhere work? Let's dive a little bit deeper. So as I said, on the left-hand side, you see the AWS cloud. It has Amazon ECS. That's the control plane, fully managed by us. One additional service that we leverage is the AWS Systems Manager. The AWS Systems Manager establishes the hybrid connection and establishes the trust with the self-managed compute that you have. So essentially, once you install the SSM agent on the compute on the right-hand side, that SSM agent ensures that these are the compute that you want to use, and this is the account that I want to connect and use this compute capacity with. So the first step is to install the SSM agent. Once you have done the SSM agent installation, then the next step is to install the ECS agent. The ECS agent is very similar to what you're running on an EC2 or on a Fargate instance. It's just expanded to support the self-managed compute scenario. And it does the same thing. It will coordinate with the control plane in terms of creating the task and managing the task lifecycle and so on and so forth. So when you install the ECS agent, you have to specify which ECS cluster you want to connect with. Okay. So SSM agent establishes the trust that these are the compute I want to use. This is the account I want to connect to. ECS agent establishes the connection with a specific ECS cluster. Okay. Once you have done this, then you are ready to launch the tasks. All you have to do is call the ECS APIs. Everything remains the same. It's the same process. Call the same APIs. All you do is you mention an external launch type. When you call the API, you tell the task to have an external launch type, which gives the signal to the ECS scheduler that, oh, I need to send this task to the external capacity that is connected with me to the cluster. Okay. By the way, all of this works seamlessly with other AWS services as well. So for example, if your task that you're running on-prem wants to connect to an AWS service such as S3 or RDS or SQS, then we will provide it with the IAM credentials, and it will be able to talk and communicate and leverage those services as well. A good example is that we will be able to send the logs to CloudWatch and the metrics to CloudWatch. And we will see some of these things when we go through the walkthrough. So before we dive into the walkthrough and take a close look of how these things are functioning, I wanted to describe the use case a little bit. On the left-hand side here, you have a ECS Fargate task. So this is a task which is running on the AWS cloud. The task is very simple. It has an EFS file share that that's attached to it. It takes a signal from the SQS that a file has arrived in a source folder. Once it gets the SQS message that that particular file has arrived, it will grab the file, it will do some processing and put it in a destination folder. It's a very simple task, but it is a very common task as well. Like there is a lot of file-based data processing that goes on. But the key thing is all of this is running in AWS cloud. Okay, so a task which takes a file, does some processing, puts it in a destination folder, okay, based on an SQS event. Now, let's say, imagine a scenario that you have a data center and you are dealing with some sensitive data, which you can't, at least in the time being, can't take it to the cloud. So you want to have the same task, same process workflow, but you want to analyze the files that are in an NFS share in your data center. So everything remains roughly the same. The task is the same, the logic is the same, but now instead of operating on EFS, you want this task to run in your data center, take the files from NFS and process it, but you don't want to create another queue and so on and so forth. So you still want to use SQS, okay? So in summary, you want to do a few things. First, you want to run this task in your data center, number one. Number two, you want this task to be able to talk to SQS so that it gets the signal, right? And number three, you'd want to monitor and send the logs and metrics for this task, okay? So let's take a look at how we can achieve all of this in a kind of prototype hybrid scenario using ECS Anywhere. So here I have my task, which is I created the stack which is in the cloud using Copilot, which is a command line tool. So as you can see here, I have named my application ECS Anywhere Copilot. This is the stack that is running in the cloud. There's one task, it's running in US West. It has an EFS volume attached to it, right? It talks to a source folder and a destination folder on that EFS volume, and it is communicating with an SQS, the queuing service. It takes the events from there. So what does this task do? What it does is, if I go and I will open a shell into this task, into this container that is running. And again, this container is running as an ECS Fargate in the US West region, okay? So I opened a shell into this using the exec command. And I can see that the data folder, this is backed by the EFS. This data volume is mounted backed by EFS, and there are two folders, the source and the destination. So I'm going to go ahead and create a couple of files in this source folder. Remember, this task does the file processing. So I created few files, and I'm going to just do a quick check that the destination folder is empty. There's nothing in there. And we will send some signals to this task from the SQS service. So I go to my console, I open the SQS service, and I say, hey, file 001 has arrived. And the task is going to pick it up and do something with it. Essentially, it will change the name of the file and put it in destination folder. Although this looks like a simple exercise, this is, as I said, it's a very common file processing activity that we see across many scenarios. Okay, so that's what is happening in the cloud. And we said we want to take this task and we want to run it on-prem. So in my data center, I have these two blue terminals. They are my on-prem hosts. And what I'm going to do here is I'm going to prepare these on-prem hosts so that I can launch containers using ECS Anywhere. Okay. So first of all, I created a separate cluster. You can use the same cluster too, but I created a separate cluster named ECS Anywhere cluster. Okay. I created a name for I created a role name for these instances. It's called the ECS Anywhere instance role. I will describe that a little bit more. And then I am going to go ahead and create this cluster. I'm going to go ahead and create this role. And then I will essentially ask for an SSM activation pair. What the SSM activation pair does is it will give you an activation code. So you see here an activation code and an activation ID. When we install the SSM agent in these two blue boxes, which are on-prem, I will use this activation code. And essentially, this is the mechanism by which we establish that you want to use these machines. These are the machines on which you're going to run the containers. So this activation code is the one that establishes the connectivity with the SSM manager. Okay, this is the first key piece that you will need. Now, a little bit about that instance role. Since you have this external machine and you want to connect it to an ECS cluster, it will need some permissions, and very similar to an EC2 instance, it will need some permissions and roles. So that's what is baked into that ECS Anywhere instance role. By default, we provide you the equivalent of EC2 instance role and an SSM related role. So you can look at the documentation, but those roles and permissions are associated with the container instances, the container hosts. Okay. We will also have roles for the container, the ECS agent. The role for the ECS agent is called the task execution role. And that role essentially enables ECS agent to pull images from ECR. It enables it to send logs to CloudWatch on behalf of your task, right? So that's the task execution role. So we have two different IAM roles, one for the container host and the other one for the ECS agent, so that it can pull images and send logs. So that's great. So we ran, this is just an automation. All the steps are documented as well. All I did here was I created a cluster, I created a role, and I created an activation pair, activation code and an activation ID. So far, so good. Next thing what we are going to do is we will export all of these variables. Right now, I don't have any Ansible or sort kind of automation, just two machines. So I'm just going to export these variables there. Before that, you can download the installation script. So that SSM agent and ECS agent, you don't have to install them manually. We provide a built-in installation script. You can just fetch it from the S3 bucket that we have. Once you have the install script, I'm going to set these environment variables. And then we will run the installation script. Okay. Once you run the installation script, and you can see that in the installation script, I provide the cluster name, which cluster you need to connect. I provide that activation ID, I provide the activation code, and which region you are connecting. So it's pretty simple, straightforward. Once this completes, then you will have these two instances connected to that cluster, the ECS Anywhere cluster that we created. Both of these instances will get connected to those. And you can see that in the console. So when you switch to console, you will see that you have the ECS Anywhere cluster here, right? If you go to ECS instances, you will see the two instances connected there. Their name starts with MI. The MI stands for managed instance, and that represents your external. And you also see that the ECS agent is also running as a container. And as I said, the installation script install the SSM agent and ECS agent. Okay. So now, so far, let's just recap what we did. I have a stack running in my cloud using the ECS Fargate. The task is running. It operates on NFS. You saw that, and it communicates via SQS. And I wanted the same task to run on-prem. So I have two machines, and I connected them successfully using the ECS Anywhere offering. I installed SSM agent, I installed ECS agent, I connected both the machines to the ECS Anywhere cluster. Now what we are going to do is we will launch the task in this ECS Anywhere remote machines that I have connected. Okay. So everything about the task remains the same. It's the same task that I have running in my cloud and as the ECS Fargate. So what I'm going to do is I'm going to just grab all the task definition, service definition, and everything, and I'm just going to change the external type. And I've essentially automated that here. So you will see here that I can pull all the service definition and task parameters. And once I extract all of that, I will just create a new task definition, which will have an external launch type. And I will highlight that. So if I pause that here, you see that the launch type is changed to external. And that's pretty much all I needed to change, right? Once I do that, when I send the create task command, the ECS scheduler knows that I need to create this task in the external instances that are connected to the cluster. Okay, so let's see whether my create script worked and whether it has created a task or not. So as you can see here, you have the ECS Anywhere cluster. You have one service created there. You have one task, right, which has a replica count of 1. And you can dig into the details of the task, and it is running. So now let's see if this task can actually operate on the local NFS, right? So the local NFS is mounted as a data volume on each one of the machines where the task is running, on both of those machines, okay? So I'm going to go and do the same thing. I'm going to create in the source folder on that NFS volume, I'm just going to create the 2 files, same as what we did before, 001 and 002. And I'm going to send the command via the SQS. I'll send the message to the task. It's the exact same thing that we did before, except that this is now operating on the NFS, and the task is taking the message from the queue, which is running on AWS. So truly hybrid experience. You are able to process the files that are in your data center that have the sensitive data, but you didn't have to do any hard work. You didn't have to install any complex container software. You didn't have to worry about how am I going to connect this task to the SQS. The tokens and everything were taken care of, and the processing is done. Okay. One other thing that you can check is that when you run the tasks, you will be able to send the logs and those metrics to the CloudWatch. That's what I mentioned. It already works, right? So let's just create a separate file by name of 57. We didn't do this in the Fargate task, right? So it will help us understand that this is actually running in the external instance. So once you do that and you go to the CloudWatch log group, you will see that the logs from the task in terms of processing that 057 named file is sent to the CloudWatch. Okay. So real quick, we have achieved all of this. We created an ECS cluster. We connected your remote hosts. We launched the task, which talks to your local data. We launched the task that connects with the SQS, and it sends the logs and metrics to the CloudWatch. And all that we had to do was run that installation script, create a cluster, create few roles, and that's it. So the very common hybrid use case was addressed very easily in using ECS Anywhere. And that's is the essence of ECS altogether, right? That powerful simplicity to be able to run containers anywhere is what we want to enable with this offering. And that has resonated well with the customers thus far. And the same use cases that I mentioned, hey, we want to run some of the containers in the compute outside of AWS because of the data governance. That hybrid use case is very common. And the beauty is that you're using the same APIs, the same operational workflows. Modernization is another big use case. People want to modernize the legacy monolithic applications. They want to containerize them and run it on-prem because of the data gravity reasons, right? Or data latency reasons. And the third very, very innovative and I love this use case is there are a lot of smart devices and smart assets out there that are generating a lot of data, like the factory floors or ships and retail sites and everything. And the volume of data is such that it probably doesn't make sense to send all of them to the cloud. So you want to do some edge processing. You want to run some containers which will analyze the data, enrich the data, and then send it to the cloud, right? So that data processing on the edge is also a very nice use case that we came across when we engaged with the customers on ECS Anywhere. Here are some of the real customers that you have used this have used ECS Anywhere. Cyber Agent is a large internet advertising company out of Japan. They have the cloud footprint, and they also have a pretty sizable on-prem footprint. And the key thing for them is to be able to manage the hybrid scenario without having to install complex software on-prem and so on and so forth, right? So the fully managed control plane of ECS is very, very appealing, was very appealing for Cyber Agent, and they're able to manage the hybrid footprint without any complexity. Getter is one of the pioneers in grocery deliveries and food delivery, very popular in Europe. They are looking to expand their offering. They are looking to create another new offering which deals with financial transactions. And there is a lot of sensitivity and compliance requirements around those transactions. So they needed a solution which can store this data and process this data in a local geography. The same kind of use case that we saw in my toy example, right? And that compliance is very important, and that's the fact that the data needs to reside in a particular geography where there may not be access to AWS regions is a great use case for ECS Anywhere as well. And again, as I said, like this is one of my most favorite use cases. Everyone knows that factory floor equipments are very expensive. They, there's a lot invested in them. So Siemens manages a lot of these equipment. Those factory assets, they generate a lot of data, and sending all of that data to the cloud, as I said, is probably not very productive. So what Siemens wants to do is they want to run containers which will gather the data coming out of the factory machines. Those containers will analyze it, enrich it, process it, and then it will generate a set of insights that is available to their customers as a multi-tenant SaaS offering. So if you are the owners of the factory floor, you can simply go to the portal and see what's happening with your machines. So brilliant use case, right? Like you have hundreds of factory floors. You don't want to go ahead and install control planes and schedulers and all. That's just not feasible. So with ECS Anywhere, since the control plane is in the cloud, you can simply run the containers, gather the insights, and bring value to your customers. So I love this use case very much. Just to recap what all things are already released, as I mentioned, ECS Anywhere is already generally available. It was launched in May. All of these features like fully managed control plane, you will be able to run the tasks and services. You can even scale the number of tasks, right? Like, so the auto scaling at the application level is already there. You can use placement constraints. So if you want to divide your compute capacity into, let's say, expensive hardware and cheap hardware, then you can partition it and you can guide the containers to the right set of hosts. The task IAM already works, right? Integration with AWS CloudWatch, all of those things are already in place. So with that, just to recap, ECS, the whole principle about ECS is that the fully managed control plane, with Fargate, no data plane, and we want to bring all of that simplicity for you to run the containers anywhere and everywhere, right? And that's really the guiding principle behind Amazon ECS Anywhere. So you get the fully managed control plane, which is in the cloud. You get the same API, same tools, launch the containers pretty easily, and manage your hybrid footprint and modernize the applications that you have on-prem or in any other self-managed compute. So with that, the tutorial that the demo that I walked through is available. Just search for ECS Anywhere tutorial in our AWS Containers GitHub repo. It's created by my esteemed colleague Massimo. It's a really good tutorial which will give you a good close view, and you can look at the files which will explain all the IAM roles and all the other steps that you need, they are covered in great details as you look through the files in there. And if you want to take a much larger tutorial from end to end, like CI, CD, and all the aspects of it, then there is a brilliant workshop created by my colleagues in the ProServe group, and it's available at the ecsworkshop.com. So with that, I think we can open it up for questions.